Okay, so this is a quick review on how to work out the problems in the study guide. We'll begin with number one. A study found that the mean amount of time cars spent in driving through for a certain fast food was 156.1. That's the mean. And assume that the drive times are normally distributed and the standard deviation is 29 seconds. And this is a normal probability questions. Find the probability the randomly selected car will get through the restaurant in less than 111 seconds. So this is going to be normal distribution questions. We need the probability of x less than 111 seconds, and you're going to use normal CDF for this. You need a lower bound. So with less than, the lower bound is the tail on the left, which is we usually use negative a million or billion. And then the upper bound will be 111. And then the mean, which is given in the question right here, 156.1. And then the standard deviation, which is 29 seconds. And let me show you how to do this on the calculator. So you go to second, distribute, normal CDF. We don't use the PDF, just the CDF. So negative a million, and then 111, then the mean, which is 156.1, and then 29, and enter, paste, and enter, and the answer is 0.0599. okay. For B, what's the probability randomly selected car will spend more than 200? So that would be normal CDF. 210 is the lower bound, upper bound is a million, and then 156.1, and then the standard deviation 29, and you do the same thing as in part A. What proportion of cars spend between 2 and 3 minutes? So that's going to be normal CDF. Okay, lower bound is 2 minutes, but you remember the question is in seconds, so you have to change this to seconds. 120 seconds, 180 seconds for 3, and then 156.1, and then 29. Would it be unusual for a car to spend more than 3 minutes? Okay, more than 3 minutes, first of all, you have to figure out what's the what is the probability of x being greater than 3. So you will have to do normal CDF, three, which is 180 seconds, and then the upper will be a million, and then 156.1, and then 29. If your answer is more than 5%, then it's not unusual. If your answer is less than 5%, then it is unusual. And this is how you answer this question. Okay, next question. The graph of a normal curve is given. Use the graph to identify the value of the mean and the standard deviation. Well, the mean is right the value in the center, so it's going to be 100. And the standard deviation, you move to the tail of the curve, you have a 3 standard deviations. So we're going from 102 to 104 to 106, 108. So, and here you get 98, 1 standard deviation. Well, I think it's between 100 and 108, and divide that by 3. So I would say 8 divided by 3, so it's about 2.6, and this is about 100, and that should give you the answer. Well, I inputted the 2.6. The system did not mark it wrong. So I'm assuming the end of the tail is going to be at 106. You can ignore the 108 here. It's a little bit hard to tell. So if you go from 100 to 106, it will give you 6 and divide that by 3 since there is one standard deviation. So if I give you this question on test, I wouldn't put the 108 and 92 because they're confusing. If you put 2, that should work there. Next question. An educator wants to determine whether a new curriculum significantly improves standardized test scores for students. She randomly divides 80 students into 2 groups. Group 1 is taught using the new curriculum, while Group 2 is taught using traditional curriculum. At the end of the school year, both groups are given standardized tests and the mean scores are compared. Determine whether the sampling is dependent or independent. Indicate whether the response variable is qualitative or quantitative. Since you're doing 2 groups in 2 different classes, they are independent. So it's going to be probably C, isn't it? Because individuals selecting one sample of do not indicate which are to be in the second sample. Yeah. Indicate whether the response variable is qualitative or quantitative. Well, since you're going to see how well they do on the test, and these are scores, actual scores, so they are quantitative. So it is a numerical measure. And here you go. You get 100% here. Next. The relative frequencies represent the length of phone calls on George's cell phone during the month of September. Determine whether or not the histogram indicate that the normal distribution could be used as a model for a variable. It looks like very much like a normal curve, approximately normal curve. So it has the shape of the normal curve. So we are being asked to check the claim that P is less than 33%. So that will be your H1, and your HO, of course, will be the equality statement, 33%. And this is where the claim is. Okay, first of all, we need to check in this question the condition of the test are met. So what is P0? P0 is the value right here. So we need to verify that N, which is what? 1086 times P0, which is 0.33, times 1 minus P0, which is 1 minus 0.33, is bigger than 10. You have to check that. And let's see what the value is. 1086 times 0.33 times 0.67 equals 240.1. So you'll just put here 240.1, which is bigger than 10. So the conditions of the test are met. The sample size should be always less than 5% of the population. We can make this assumption. You can also assume that the sample is random, so then the requirements of the test are satisfied. For HO, it's a proportion, so that's an equal statement, and you put 33%, which is 0.33. And here you're going to put P less than 0.33. And we're going to go to the calculator and run the test here. So let's run the test. So you go to Stat, Tests. It's a proportion Z test, number 5. Enter. Okay, P0 is 0.33, as you notice. Okay. X is what? We have 336. N is 1086. I'm just entering that value. I'm typing it in. And we need to, the alternative is less than, and then calculate. And Z is negative 1.44, and the p-value is 0.0743. There's a p-value. And 0.073, what are we doing it at what alpha level? 5%. So this is bigger than 5%. So no, we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you conclude that there is not enough evidence to support the claim. So it's a no here, not enough evidence. Do not reject the null hypothesis. And that's it. Next question. A researcher wishes to estimate the percentage of adults who support abolishing the penny. What size sample should be obtained if he wishes to the estimate to be within 4 percentage points with 99% confidence? So let me bring let's erase first. Okay. So here, the confidence level is 99%. The critical value, guys, is for 99% is trying to select ZC or Z0. It's 2.575 for 99%. For 95% is 1.96, and for 90% 1.645. The margin of error is 4%, so E is 0.04. And here's the formula to find the sample size. In A, we already know a previous estimate with 24%, so P hat is 24%. Q hat is the complement, it will be 1 minus 0.24. And here's the formula for N. N is P hat, Q hat, ZC over E squared, which is P hat is 0.24 times Q hat 1 minus 0.24 is 0.76 times ZC is 2.575 divided by 0.04 squared. And let's compute this. If I bring the calculator up here, guys, and you get 0.24 times 0.76 times open parentheses 2.575 divided by 0.04 close parentheses and raised to the second power, and it's 755.89. You have to round up, so your answer should be 756. For the second one, he says no preliminary estimate is given, so your N is going to be for the second one. If no preliminary estimate, you just use 50% for P hat and 50% for Q hat. So it will be 0.5 times 0.5 times exactly the same thing here, 2.575 over 0.04 squared. And whatever answer you come up with, you round it up and you put it in there. A pediatrician wants to determine the relation that may exist between a child's height and head circumference. She randomly selects 8 children from her practice, measures their height and head circumference, and obtains the data shown in the table. Complete parts A through E. Okay. If the pediatrician wants to use the height to predict head circumference, determine which variable is explanatory variable and which is the response variable. So the response variable is the dependent variable, and the explanatory variable is the independent variable. So height will be explanatory and head will be response. Okay, that will be right here. And now he wants a scatter plot of this. I'm going to show you how you could do that in Static Crunch. Okay, you can see it's Static Crunch right here. You just go to stat and you go to regression and you go to simple linear. This is simple, and then X variable is height, Y variable is head circumference, and just select compute right here. Let me show you the compute right here, and here's what you get. If he asks about R, this is the value of R right here. This is R square. This is standard error of the estimate, and this is the equation. Head circumference, that's the Y, equals 10.42 plus 0.2567x. And then if you want to see the sketch, the graph, this is the graph. Okay, so you can match it from here. This is R, you already. Now, does a linear relationship exist between height and head circumference? Here's how you can tell. You can open the table of critical values right here. Let me show you how to use this table. Okay, what's n here? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I got 8. The critical value is 0.707. And if the value of R in absolute value is bigger than the critical value, then relationship does exist between the two. So yes, you can say the variable height and head circumference are positively association. No, because R is positive, so it's a part D right here. Okay, and because the correlation coefficient is greater than the critical value, which was 0.707, you just put it right here. It's as simple as that, using the critical value. Convert the data in E to centimeter and recompute the linear correlation coefficient. So you just, to convert inches to centimeter, you have to multiply by 2.54. Just multiply each one by 2.54, and then just use a static range again to do it. Okay, find the probability and interpret the results. The population mean annual salary for environmental compliance specialists is about 60,500. A random sample of 38 specialists, so that's X bar, 60,500. Let me just delete here, because we're gonna need that. So let me just go back. A random sample of 38 specialists drawn from this population. What is the probability that the mean salary of the sample is less than 57,500? So he wants a probability of X bar less than 57,500. It's not an individual here. He says, what's the probability of the sample? So you're going to go to normal CDF. You're going to put the lower bound, which is -1,000,000. Upper bound is 57,500. The mean was what? Let me check. 60,500. The standard deviation is 5,900, and the sample size is 38. 60,500. And now the standard deviation, 5,000, but it's not, when you work with samples, you don't just use the standard deviation. You have to use the sample means, the standard deviation, and which is 5,000 divided by the square root of the sample size, 38. And that should give you the correct answer. Oh, 5,900. I made a mistake here, so I'll just change this to 5,900. How do you do this on the calculator? You go to second, distribute. Second, and variables. Oh, it's not working. Second and variable. Now it's working. Oh. Normal CDF. Enter. Okay, lower is negative million. Upper is 57,500. Mean is 60,500. Sigma is 5,900. And don't forget, you have to divide by square root of 38, the sample size, whatever it is. And then paste. And your answer is 8.609 E minus 4. E minus 4 means you have to move the decimal place 4 digits to the left, so it will be 0.0008. Okay? So 4 decimal places will be 0.0008. And let me just check the calculator. Oh, 86, so that will be 9, sorry. Was wondering about the 9. Okay, if you change this to a percent, that will be 0.09%. So only 0.09% will have a mean. So this is very unusual. So this is an extremely unusual event. That would be the answer right here. Suppose the monthly charges for cell phones plans are normally distributed with mean 61, standard deviation 20. Draw the normal curve. So you just put 61 in the middle and add 20, 20, 20 on the right, 20, 20, 20 on the left. So which one would that be? It seems to me like it is the first one. 20 will give you 81, another 20, 101, and so on and so forth. So that would work. Shade the region that represent the proportion of plans that charge less than 41. Well, less than 41, that's not correct because 61 has to be in the middle. So that would be the one right here. Okay, interpret it. Select the correct choice below and fill in the answer box. Okay. Suppose that the area under the normal curve to the left of 41 is 0.1587. So this area here is 0.1587. How do you interpret that? It means that the probability that a variable has a value of x 41 or less is 0.1587. That's one meaning. Less than 41 right here. All right. What's the probability of x greater than 43 given a mean of 50 and standard deviation of 7? It's on the calculator, guys. You go to second, distribute normal CDF. Okay, greater than 43. So 43 is the lower bound. Upper bound, the sky is the limit. Mean, he says, what was the mean in this question? 50. You don't see the 0, but I'm picking up the 0. And the standard deviation, we need a standard deviation, which is 7. And that's it. So 0.8413. So you enter this answer. Which of the following correspond to probability of x greater than 43? Well, it must be C. Because the mean is 50, right in the center. Greater than 43 means 43 and up. And find the probability of x greater than 43. We just did that. For students who first enrolled in 2-year public institution in recent semester, the proportion who earned bachelor degree within 6 years is 0.391. The president of a certain college believes that the proportion of students who enroll in her institution have a lower completion rate. So lower completion rate. Okay, let's write the proportion equal, and lower means less, 0.31 391. Interpret type 1 and type 2 error. Type 1 error is when you reject the null hypothesis when it is true. So a type 1 error will be okay, the president, okay, when you reject HO when it is actually true. So let's see which one. The president rejects the hypothesis that the proportion is 0.391 when in fact it is true. That's type 1. Type 2 is when you fail to reject HO when it is false. No, when in fact the proportion is president failed to reject the proportion of students who earn bachelor degree is 0.1 when in fact the proportion is less. Yeah, when it is false. It's false means the alternative hypothesis is true. Suppose you toss a coin 100 times and get 76 heads and 24 tails. Based on these results, what's the probability of the next flip result in a tail? Well, it will be 24 divided by 100, because you have from each 100 there are 24 tails. Sorry, 100. So it will be 0.24. What did we put here? Oh, the reason why I got incorrect because I did not compute the answer. So let's compute the answer. So it's 0.24. He says to 2 decimal places. Yeah, I was wondering why I didn't pick it up. Suppose a normal monthly charge for cell phones are normally distributed with mean 59 and standard deviation 15. Draw the normal curve. So 59, and look for 3 15s to the right and 3 15s to the left, or just at least one standard deviation that's correct. It can't be B and it can't be C. It's either D or A. And you can see 59 plus 15, that's 74, so it must be A. Shade the region that corresponds to charges less than 44. That's it right here. It can't be this one because 59 has to be in the center here, which is the mean. And then select the correct choice below. What does it mean for probability of the area under the curve to the left of 44 to be 0.587? I think we did this one. The probability 0 that is less than. Always area to the left means is less than 44. All right. Determine the point estimate of the population proportion, the margin of error for the following confidence interval, number of individuals in the sample. Okay, the point estimate is for the population proportion is p hat. And the way to find a p hat, if you have the lower and the upper bound of the interval, just add them up and divide by 2. So it will be 0.094 plus 0.446 divided by 2. And you need to do the math here. The margin of error, when you have the lower and upper bound of the interval, you subtract the lower from the upper and divide by 2. So it will be 0.446 minus 0.094 divided by 2. The number of individuals with the specified characteristic. Once you find the point estimate of the population proportion, just multiply by the sample size, which is 1500. So let's say this turns out to be 0.044645 and 54, I think. So it's going to be 27%. So you just take 27%, which is 0.27, and multiply by 1500, the sample size, and that should give you the answer. Suppose a doctor measures the height x in, and this is chapter 4, guys, and head circumference y of 8 children and obtain the data below. The correlation coefficient is 0.938, and the least square equation is this. Compute the coefficient of determination r squared. Just square r, which is 0.938 squared. 0.87, how many digits he wants? Round to 1 decimal place, so it will be 88.0%. Okay, interpret the coefficient of determination. It means 88% of the variation in the y variable can be explained by the variation in the x variable. So in the variation of the head circumference is explained by the least square model. A study was conducted that results in the following relative frequency histogram. Determine whether or not the histogram indicate that a normal distribution could be used as a model. Well, it's not a normal distribution here. It's not bell-shaped. Could not be used. Some experts believe that 17% of all freshwater fish in the country have such high levels of mercury that they are dangerous to eat. Suppose the fish market has 350 fish tested, and 72 of them have dangerous level of mercury. Test the hypothesis that this sample is not from a population with 17% dangerous fish, assuming that this is random sample. Not is not from means not equal to. So this is going to be your null and the alternative hypothesis, and we're going to bring the calculator up and run the test. This is going to be a proportion z test, number 5. Not the number 5, I didn't pick number 5. Oops, it went back too far. Now, okay, 0.17 is the value in the null hypothesis. And then 300 fish and 72. So 72 were dangerous to eat out of 350 and not equal to, and then hit calculate. So z is 1.78 and the p-value, guys, is 0.0753. And you put the statistic there around to 3 decimal places, so without the 3 there. What's alpha here? 5%. Well, this is bigger than alpha. We failed to reject HO. And if you fail to reject HO and the claim is in H1, you cannot support the claim. So there is not enough evidence to support the claim. So that means population proportion is not different from 17%. Determine whether this graph can represent a normal density curve. Definitely it's a no, because it has to go along the x-axis, the tails, and don't touch. A simple random sample of size n drawn from the population that's normally distributed. The sample mean x bar is found to be 115. The sample standard deviation is 8. Construct a 99% confidence interval. So just go to stat. When you have x bar and you have the sample standard deviation, it's a t interval. Enter. And look, guys, how straightforward it is. So the mean is 115 and the sample standard deviation. Once he give you a sample standard deviation, it's t. Don't use z at all. That would be wrong. Stat. Enter. Okay, x bar is 115. Standard deviation is 8. And he gives you a sample size is 23. And confidence level is 99. Calculate. So 110.3 and 119.7. And then he gives you a different sample size, so you just do that. And how does the sample size affect the margin of error? The smaller the sample size, the larger, the bigger the margin of error. You know, the more they put in the sample, the lesser the margin of error. So this is all t interval. You can use it to in t interval here. What's the probability of x between 34 and 65? The mean is 50 and the standard deviation is 7. So 7, if you added 3 7s here, it will take you almost to 71. Okay, so which one is the correct graph? I think it's going to be C, because look here, this is shaded right here. And what's the probability here, guys? It's normal CDF, second and variable. Lower is 34. It's easy when you have the bounds here. And then 65. Then the mean is 50. Then the standard deviation is what? 7. 0.9728, and you can see it's most of the graph, so I'm not surprised that it's almost 100%. So question 21, which histogram depicts a higher standard deviation? You can see in the first one, the data is more spread out from 30 to probably 80, but here it's 40 to 66, so I would say it's A, because the distribution has more dispersion. A survey of 300 randomly selected high school students determined that 172 played organized sport. What's the probability of randomly selected high school students to play organized sports? It will be 172 divided by 300. So you just do the math. Choose the correct answer below. Interpret the probability. Okay, so let's see what 172 divided by 300 is. I got 0.573. So if 1,000 high school students were sampled, would you expect that about, not exactly, 573 of them, because I got 0.573. If you multiply it by 1,000, it will be 573 of them would play organized sports. Let the sample space S be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose the outcomes are equal likely. What's the probability of the event 2, 3, 6? The probability by definition is the number of favorable outcomes divided by possible outcomes. So how many possible outcomes? I have 10 here. So at the bottom it's 10. And what's the event? It's 3 outcomes. So it would be 3 over 10, 0.3. Don't think too much of this question. It's just basic probability question. The following data represents the flight time in minutes of a random sample of 7 flights from one city to another. Compute the range and the sample standard deviation. You could use StatCrunch here if you like, and open it in StatCrunch, or you can use your calculator. So you go to Stat, Summary Statistics, Columns, select this column, hit Compute, and here is the range, which is 27, and standard deviation is 8.83. You also can do this one using the calculator. You will have to go to Stat, Edit, you will have to put your data in L1 and then go to stat, calc, one variable statistics, and frequency list, make sure it's empty, and hit calculate. And then you can find the sample standard deviation. The sample standard deviation is S. If he tells you the data set is the population, then your standard deviation will be sigma, but most of the time it's S. The first one is the mean. And remember, those values don't reflect on this answer because I did not enter the data in L1, but I'm just showing you how to do it. A traffic safety company published report about motorcycle fatalities and helmet use. In the first accompanying data table, the distribution shows the proportion of fatalities by location of injury for motorcycle accidents. Second data shows the location of injury fatality of 2,068 riders not wearing a helmet. Compute A to B. Does the distribution of fatal injury for riders not wearing, this is section 12.1, guys. Not wearing a helmet follow a distribution for all riders. Use alpha equals 10% level of significance. What are the null and the alternative hypotheses? And these are the table of percents that we were given here. Okay, so let me just close this for now. Okay, for goodness of fit test, this is section 10.1. Your null hypothesis should be the distribution is as claimed, and alternative, the distribution is not as claimed. So let's see which one. Distribution not wearing a helmet does not follow. No, that can't be. The distribution of follow the same distribution, so that must be the one. Now we need to compute the expected count. The expected count, guys, is a percent of the total. So if I just go here, and the first percent is 0.570 for multiple locations, so you just do 0.570 times the sample size, which is 2068. And then for the second one, I need the table again. Let me just put it here. 0. What's the next percentage? 0.31 times 2068. Then the next one, neck, 0.03 times 2068. Thorax, 0.06 times 2068. And finally 0.03. And if you compute the math, you will get 0.57 times 2068, which is 1178 point, he says 2 decimal places. So that would be 1178.76. The second one, guys, will be 0.31 times 2068, 641.08. The next one is 3%. So it's going to be 62.04. And this is what? 6%. So double 62.04. So it will be 124.08. And last one, 62.04. If you add up the expected count, they should add up to 2068. Okay, calculate the p-value. Let me show you how to perform the goodness of fit using the calculator. So just go to stat, tests, scroll up, it's right here, D, with the GOF test. Okay, we're gonna put the observed values in L1 and L2, so let's put them in there. You have to do the L1 and L2. This is the only way to do a goodness of fit test on the calculator. So L1 shouldn't take time, just to do that. So we got what? 1028, 879, 33, 81, 47. And now I'm gonna go to the second one, 1178.76, 641.08, 62.04, 124.08, and 62.04. And let's run the test now. Now we can run the test. Okay. Degrees of freedom or number of categories -1. I have multiple location, head, neck, thorax, and abdomen. So I got 1, 2, 3, 4, 5. 5 minus 1 is 4. Okay. And then run the test, calculate. And here's the test statistic. It's 139.77. And the p-value is 0. E minus 29 means you have to move this 29 decimal digits to the left, so it's 0. And so you write the p-value as 0. And then reject the null hypothesis because the p-value is alpha. And let's see what the claim is. Does the distribution of fatal injuries, rider not wearing a helmet, follow the distribution of all riders? Since we rejected the null hypothesis, then we say there is enough evidence to reject the claim that it does follow the distribution of all riders. So reject HO, and M must be here. Okay. So that would be the answer to this question. Okay, second video will have the remaining questions. So I'm stopping the video right now.